Carburetor Theory of Operation and Servicing Procedures. The topics in this module apply to most carburetors that have been used on Evinrude and Johnson outboards. All internal combustion engines run on a mixture of air and fuel. To operate efficiently, an engine must burn approximately 12 to 14 units of air per unit of fuel. The ratio of air to fuel is based on weight, not volume, and varies with engine speed and operating conditions. The carburetor's job is to provide the proper ratio of air to fuel. If it's not correct, the mixture won't burn properly. An air-fuel mixture with too much fuel is described as being too rich. Mixtures that are too rich waste fuel, and they accelerate the formation of carbon deposits on pistons, rings, combustion chambers, and exhaust ports. These deposits reduce performance and can even damage the engine. Rich mixtures can also foul spark plugs. This is because fuel and oil accumulate on the spark plug's insulator. Electricity flows through the deposits on the insulator's surface rather than jumping the gap between the plug's electrodes. This causes a misfire or miss. If deposits remain on the spark plug after the engine is shut off, it may be difficult to restart. Not enough fuel in the mixture is described as too lean. Mixtures that are too lean may burn too hot. On carbureted two-stroke engines, the lubricating oil is mixed with the fuel, so mixtures that are too lean don't have as much oil as they should. A few seconds of high-speed operation with a mixture that is too lean can permanently damage the pistons and other internal parts. The challenge is to provide the correct mixture for continuously changing load conditions and engine speeds. All carburetors rely on atmospheric pressure, which is the weight of the air surrounding us. Air doesn't weigh very much, but there are miles of it above us. Although you can't feel it, about 15 psi of atmospheric pressure is constantly pushing against you from all sides. When a two-stroke engine is cranking or running, the pistons create a low-pressure area inside the engine every time they move away from the crankcase. On four-stroke engines, the intake stroke creates a low-pressure area. Atmospheric pressure pushes air through the carburetor's throat to fill this low-pressure area. Carburetors use this principle not only to supply air to the engine, but also to move fuel and mix it with the air. Posi-drive screws are sometimes used in outboard carburetors and other applications. These screws require the use of a posi-drive screwdriver. A Phillips screwdriver will damage the head of a posi-drive screw. Conversely, a posi-drive screwdriver will damage a Phillips head screw. As always, use the correct tool for the job. Orifice drivers are designed to remove orifices safely. The driver's tip and round shank prevent damage to the orifice and to the threads in the carburetor. Several orifice drivers are available to help you remove and replace hard-to-reach orifices. Always inspect orifices closely. Look for foreign matter in the bore and physical damage to its body. Several different styles of orifices are used in carburetors. Some of the differences are obvious, while others are subtle. Orifices with quarter-inch 20 threads are stamped with a C or D, indicating the direction of fuel flow. Orifices are calibrated for a specific direction of fuel flow. They have different flow characteristics when fuel flows in the opposite direction. Installing a C orifice in place of a D orifice, or vice versa, can drastically affect engine operation and even cause serious powerhead damage. Use the parts catalog to verify the correct type and size of orifices. To remove core plugs from the carburetor body, use a small hammer and punch with an 1/8-inch tip. Drive the punch through the center of the core plug. Use several light taps of the hammer, not one or two hard blows. Use the punch to pry the core plug out of the carburetor. Do not drive the punch more than 1/8 inch below the top of the calibration pocket. Don't let this happen to you. Inspect the ports in the calibration pocket. Make sure all of the holes are clear of obstructions. Inspect all gasket surfaces for nicks or irregularities. The surface of the nozzle well should be flush or slightly below the surface for the fuel chamber gasket. Inspect all gaskets for damage. An incomplete imprint can help you find problems with the sealing surfaces. Always replace gaskets, never reuse them. The cost of the gasket doesn't justify the risk of having to do the job again. Some carburetors have a sealer that penetrates the surface of their aluminum body and float chamber. The sealer serves two purposes. First, it seals the aluminum so it will not leak air or fuel. Second, it protects the aluminum from corrosive chemicals found in gasoline. Clean carburetor parts in a shallow tray with Evinrude Johnson carburetor and choke cleaner. Never clean a carburetor by submerging or soaking it in a hot tank or harsh carburetor cleaners. The powerful chemicals can damage or remove the sealer. If the sealer has been removed, air can leak through the porous aluminum and affect carburetor calibration. Clean and test all passages in the carburetor body and float chamber with a syringe filled with isopropyl alcohol. Some carburetors have an air bleed hole in the idle pickup tube, often hidden below the high-speed nozzle. When using a syringe, you may discover fluid flowing from this bleed hole. Be careful to verify the source so you don't mistakenly conclude it's leaking from somewhere else. You can use a small copper wire to help clear longer tubes, but be very careful not to scratch or enlarge the passage. Do not use any metal object to clean orifices or calibration pockets. If necessary, you may use a round wooden toothpick, but be careful. They break easily. Never use tools designed for cleaning torch tips. Adjust shop air pressure to a maximum of 25 psi when drying a carburetor or blowing out its passages. When blowing out fuel passages, apply the air in the direction opposite to normal fuel flow. Avoid blowing air in the same direction fuel would normally flow. This could wedge foreign material more securely into the fuel passages. Carburetor repair kits are available to service most carburetors used on Evinrude and Johnson outboards. The kits contain all of the parts required for normal service repairs, including gaskets, O-rings, and core plugs. Install new core plugs with the convex side up. Use a flat-ended punch and plastic mallet to seat the plug. Then apply gasoilus sealer to the edge of the plug. The float level must be set accurately for the carburetor to provide the correct air-fuel mixture. The procedure described in the service manual provides a quick and accurate method for setting the float level. Carburetors also have a float drop adjustment. This adjustment assures the float valve will open far enough to provide adequate fuel delivery, but not so far that the needle falls out of the seat. An incorrect float drop adjustment could cause a lean mixture and damage the engine. Follow the procedure in the correct service manual. Disassembly, cleaning, and reassembly of a carburetor is a fairly simple procedure. Proper carburetor diagnosis and repair will allow an engine to provide the power and performance it was designed to deliver.